Here's question 2 on the Being John Napier project. So we're going to use the quotient property in order to divide these two numbers. So let's go ahead and set it up as if we were going to divide the numbers. 894 divided by 261. So rather than just divide those numbers, we're going to take the log of this quotient. And then using the quotient property here, this takes a division problem and turns it into subtraction. Okay, so the log, this turns into the log of 894 minus the log of 261. Okay, so again, the point here is to turn a division problem into a subtraction problem because it's faster and easier to subtract two numbers than it is to divide two numbers. So we're going to have to look up the logs of each of these numbers on our table. As we saw in the previous video, we need to first turn this into scientific notation because our log table only goes from 1 to 10. These numbers are definitely bigger than 1 to 10. So we're going to write this as the log of 8.94 times 10 to the second power minus the log of 2.61 times 10 to the second power again. Okay, so in each one of these logs, I have a product. Excuse me here for a second. Alright, and so I can use the good old product property on that one and break that up as a sum. So this is the log of 8.94 plus the log of 10 squared. Now do the same thing on the second one, minus, and now this is going to be in parentheses here because I have to distribute this negative sign to both of these when I use the product property. So log of 2.61 plus the log of 10 squared. Okay, so now let's just evaluate each one of these logs from the log table. So the log of 8.94, so I have these both set up. The log of 8.94, so this is 0.1, 2, 3, no, that's not right. That's not right at all. Okay. 0, 1, 2, 3, 4. So it's that number there and the intersection of those. So the log of 8.94 is equal to 0.951. 0.951 plus the log of 10 squared is 2. It's just that exponent right there because these are inverses, they cancel out. Minus, now I need to find the log of 2.61. So again, I already have this highlighted. This is 2.60, 2.61. It is 417.417. So the log of 2.61 is equal to 0.417. 0.417. And then finally, I'm going to distribute this negative sign to this. So this is going to be a minus 2. And these 2's, they just cancel, right? A plus 2 and a minus 2. So the only subtraction problem I have to do here is 0.951 minus 0.417. Okay, so then you have to remember how to subtract here, especially since we have to borrow 1 from the 5. So it's 11 minus 7 is 4. 4 minus 1 is 3. And 9 minus 4 is a 5. Okay, so this is equal to 0.534. This is an answer to a logarithm, which means that it's an exponent. Specifically, it's an exponent on the base of 10 because we were dealing with the common log. So what we're looking for, the answer to our original problem here is 10 to the 0.534 power. Now I don't have to do any tricks on this one because this is a number between 0 and 1, so I could look that up directly on the log table. Remember, we're working backwards this time. We're looking for 0.534, and here it is. So it's on the column with 3.4, and this is 0, 1, 2. So the log base 10 of no, that is not what I want. What I want is 10 to the 0.534 power is equal to 0.342. And that's our answer right there. We don't have to move the decimal place over. Wait a minute. Yes, I do. Because it was 3.42. There we go. 3.42. Now I don't have to move the decimal place over because it wasn't in scientific notation. So there, I'm finished with the second problem.